Nassim Haramein was born in Geneva, Switzerland and is now based on the big island of Hawaii. From as early as 9 years old, he was developing the basis for a unified hyperdimensional theory of matter and energy, which he eventually called the holofractographic universe theory. He has spent most of his life researching the fundamental geometry of hyperspace. Combining this knowledge with a keen observation of nature, Nassim discovered a specific geometric array that is fundamental to creation. His unification theory, known as the Haramein-2010 metric, is a new solution to Einstein's field equations that incorporate torque and the Coriolis effects. Together with his recent paper, The Schwarzschild Proton, his theory lays down the basis of what could be a fundamental change in our current understanding of physics and consciousness. In the past 20 years, Nassim has directed research teams of physicists, electrical engineers, mathematicians and other scientists. And he's been giving lectures and seminars for over 10 years. He's founded a non-profit organisation called the Resonance Project Foundation, where as Director of Research he continues exploring unification principles and their implications. The foundation is actively developing a research park in Hawaii which combines science, sustainability and green technology. It's a great pleasure to have Nassim here. Where'd he go? There he is. First time in Australia at a Nexus conference. Please give him a big warm welcome, Nassim Haramein.
Thank you. Thanks for having me. It's great to be here. Thank you so much. I thought there was going to be translation into Australian, so, you know, I haven't practiced but good day, mate. Not bad. I'm getting there. All right. Today we're going to learn a little bit about the Schwarzschild Proton. This is a paper I just published last year, and it won an award in Europe, which is good. I was surprised. The director of the conference came up to me. He's like, in the middle of the conference, I thought I was going to get kicked out of the conference, and, you know, because it was a pretty radical paper. It was an invited paper, so I thought, oh, I can go radical because, you know, they can't refuse it if it's invited. And, you know, he took me aside in the middle of a conference, and it was in Belgium at the math department, and I thought, that's it, you know, here it goes, you know. And he's like, I noticed on your schedule that you're leaving before the award presentation, and I thought, oh, yeah, you know, I had like set it up on purpose that way because, you know, it's like, I'm sure I'm not going to be part of that. And he goes, we'd like you to stay. I'm like, why? And he's like, well, you won the best paper award for physics. I'm like, really? Wow, we live in a new paradigm. And, you know, why was I thinking this was radical? Well, you'll see why. And I'm just going to go through it a little bit. And please don't panic. But we're going to do a little bit of math. It won't hurt. It's only going to hurt momentarily. But then it's okay, you know. It's not permanent damage. This really started when I was about 9 years old, and I went to my first geometry class at school. It was, you know, I was not doing so well at school because I had all these esoteric experiences, and I, you know, lived in a world in which, you know, I was interacting with all sorts of things and all sorts of worlds out there, and I was more interested in that than what the teacher was saying. So most of the time I didn't pay much attention, so I didn't, you know, I wasn't doing so well. And when the teacher went to the blackboard that morning and said, today we're going to have our first lesson in geometry, and the first lesson in geometry is dimensions, I was like, oh, adults know about other dimensions? I was like so excited, and then I got so disappointed. Because the teacher went to the blackboard and made a little dot like this and said, this is dimension 0 and it doesn't exist. And I was like, oh, this is not gonna go well. I knew from that moment on I was gonna fail that class. Because I was way back, you know, I was always nearest the door. and I could see the dot. So if I could see the dot, how is it that it didn't exist? And then the teacher did something remarkable. He put a bunch of dots together, made a line, and said this is dimension 1, and it doesn't exist either, because it still doesn't enclose volume. And then he put 4 lines together, made a plane, called it 2D, and said that's the plane that all your comic strip books lives in, and it doesn't exist. And I could see, like, the kids were crushed, you know. They were like, what? And then he did something miraculous. This is the equivalent of the, you know, miraculous Big Bang, you know. He did something miraculous. He took 6 of these planes, put them together to make a cube, called it dimension 3, and said, this one exists. And I was like, huh? How did that happen? You know, because I don't care if you put 100 million non-existing planes together, you don't get existence, right? If the dot that doesn't exist, right, makes the line that doesn't exist, makes a plane that doesn't exist, you don't get existence. You get non-existence to the 4th. Big issue. I didn't know at the time. Turns out many other thinkers had the same problem throughout the ages. One of them, one of the most famous one, was Buckminster Fuller. Another one was my father, actually, turns out. And, you know, they thought about it, but nobody really solved the issue. And so, why is this important? Well, this is actually the fundamental axiom that most of our physics are written on. And if we, in the math, we write those physics with. So if we have this wrong to start with, if it's incorrect or if it's incomplete, then we're going to get an incomplete or incorrect picture at the end. And so, because people learn this very early in their education, it's usually not revisited ever by the physics community. And at the end of the day, then they have superstrings theory and Calabi-Yau spaces trying to solve equation for unification for advanced physics, and they have to add, you know, planes of freedom one after the other to get like 248 dimensions of Calabi-Yau space, and the equations go on forever, and at the end of the day it doesn't add up. Alright? So when I was going home from that day, I had this long bus ride to go back to my home because I kept on getting kicked out of the schools closer to my home. A physicist later on told me in a physics conference that that's how I furthered my education. Because I had all this time to think about it, right? And so I'm sitting there, I've got an hour and a half to go, and I'm thinking, man, I gotta solve this dimensional problem. This is not happening. I can't live with this. And I'm thinking, and then the bus is getting fuller and fuller, and I thought, oh, you know, it's getting hot, and so I closed my eyes, and in my mind's eye, I extruded myself from the bus, and I started rising up from the bus, and I saw slowly the bus becoming smaller as I rose further and further, and then I saw the city I was in becoming smaller as I rose further and further and further, and then the continent getting smaller, and then I saw the earth getting smaller, and as I rose further I saw the solar system getting smaller, and like looking like a dot, and then I rose further and further, and then the galaxy started to look like a dot, and I thought, oh my God, it's dots all the way up. And then I flew back into the galaxy and looked at the solar system and flew back in and went back to the earth and found the bus I was in, and I opened my eyes and I looked at my hand and I thought, I wonder what's in there. I closed my eyes, and in my mind's eye, I flew into my hand, and I saw it was made out of millions and millions of dots. We call cells. And then I went onto the surface of one of those dots and looked really carefully, and I got finer and finer, and eventually it opened up like it was stars of dots everywhere. Billions of them that we call atoms. And then I went to one of those dots, and I looked in the middle of it, and sure enough, what was there? Another dot. And I was like, oh, it's dots all the way down. And I had this epiphany, you know, like, oh my God, maybe the universe, maybe the answer to the riddle is the exact contrary. The only thing that exists is a dot. The universe makes points of infinite division and assembles them at different scales and make everything we see. I was like looking at the people in the bus, and I could see they were made out of dots and smaller dots and smaller dots. They seemed to glow with a strange aura, and you know, at this moment. And you know, when you have these moments of epiphany, I'm sure many of you in this room had them, you know what you want to do next, right? You want to tell someone, right? And you all know how that goes usually. You get the look like, did you take your medication this morning? And, you know, so I ran home when I got out of the bus, and I waited for my mom to come back from work, and when she got home, I was like, Mom, I figured out something at school today, it's so awesome. And my mom was all excited, it's like, oh my God, he's actually enjoying school, like, oh, maybe he had a good exam, you know, for the first time in his life. And I'm like, Mom, today I learned about dimension at school, and they're wrong. I just went over like a lead balloon. And it's like, Mom, you know, I think it's the contrary, that like the only thing that exists is dots, and you're made out of dots that are made out of smaller one and smaller one and so on. You get infinite amount of dots, Mom. And she looked at me, and she said, you know what, I just worked for 8 hours, I'm real tired, I don't feel infinite at all. And, you know, she had made a point, you know, pun intended. And it's like if everything is embedded into each other to infinities, how you get boundary condition? How does things differentiate from each other? This has been a big problem. It's a chasm in our understanding. How does infinity and finite system interact? Typically we think they don't. And that has shown up in our physics really strongly. So now we have a theory for like big stuff, Einstein field equations, that predicts continuums towards singularity, continuums towards infinity, and we have a theory for the small stuff, for the atoms and the subatomic particles we call quantum theory, and quantum theory predicts bounded linear finite states. So the two don't agree. And so since then we have this thing, and so we have this chasm between the two. Einstein tried to put it together, but he couldn't. And, you know, the problem is that when you look out there, big things are made out of small things. So obviously, those physics must match. Right? Well, the chasm is much deeper than that. The chasm between the understanding of infinity and bounded state shows up in our society everywhere. I'll give you an example. Spiritual people tend